Hi, this is the first lecture for Text Unit 2. Unit 2 concerns matter. Part 1 concerns atoms, elements, and the periodic table. Alright, what is an element? An element is a substance made of one type of atom. Okay, now for this sentence to make sense, we have to talk about what we mean by type. Okay, if we remember that an atom is a tiny thing with a nucleus of protons and neutrons, and that electrons are around the nucleus, we can also remember that protons have a +1 charge, electrons have a -1 charge, and neutrons have no charge. And in a typical atom, the number of protons equals the number of electrons, so that the atom as a whole has no charge. If we remember that about an atom, the type of atom meant in the definition of element, the type of atom is determined by the number of protons, or atomic number, sometimes given the symbol Z. All atoms in a sample of an element have the same atomic number. The periodic table, of which you have a handout, either a digital copy or a hard copy, has the atomic number for each element at the top of the box. So at this point, look at your periodic table. You'll see boxes for each element. If you look in the second row, for example, you'll find the box for carbon. At the top of the box, you'll see a 6, which is the atomic number for carbon. All carbon atoms have 6 protons. The one in the picture also has 6 neutrons, and it has 6 electrons. Since it has 6 electrons, the number of positive and negative charges are equal, and the atom is neutral, just as we discussed on the last slide. We use symbols to provide information about atoms. For example, you'll see a symbol C, an alphabetical symbol C, in the box for carbon. If you look elsewhere in the table, up at the top left, you'll find the box for hydrogen, which has the alphabetic symbol H. If you write a symbol for a hydrogen atom, you should start with the alphabetic symbol H and include a subscript over here, which is equal to the number of protons. Now this information, the letter and the subscript, is really provided twice, or I should say the letter and the subscript are redundant, because this number tells you that the atom has 1 proton, and the H tells you that it's a hydrogen atom and therefore has 1 proton. Superscripted is another number, the mass number, given the symbol A, which is equal to the number of protons plus neutrons. Therefore, the mass number for this, since the mass number for this hydrogen atom is 1, the number of neutrons is actually 0. Here we have symbols for sodium and magnesium ions. An ion is a charged atom. The symbol for sodium has the alphabetic symbol, Na in this case. The subscript is an 11, which is the atomic number of sodium, and that also, that appears here. And remember, it tells you the same information as the alphabetic symbol. The mass number is 23 in this case. Since the mass number is 23, there are 23 minus 11, or 12 neutrons in this sodium atom. And you will also see a positive charge here, a superscript on the right-hand side. That means that the atom as a whole has a +1 charge. When an atom is charged, or an ion, that is always because the number of electrons has changed relative to the number of protons. So, for example, a positive charge here means that there is one less electron than protons, or one less negative charge than positive charge. There are therefore 11 minus 1, or 10 electrons in this sodium atom. Symbol for this magnesium atom has a subscript 12 to show the number of protons. The mass number is 24, which means that there are 12 neutrons in addition to the 12 protons. The charge is positive 2, which means 2 electrons have been taken away, which means that we have 12 minus 2, or 10 electrons for this magnesium atom. Isotopes are atoms of the same element with differing numbers of neutrons. For example, I show here 2 different carbon atoms. Both of them have atomic numbers of 6. However, one has a mass number of 12, indicating it has 6 neutrons. The other has a mass number of 14, indicating it has 8 neutrons. Most carbon atoms, well over 90%, are carbon-12 atoms, but there are carbon-14 atoms, and there are carbon-13 atoms in nature as well. Carbon-14 atoms in particular are what make possible carbon dating, if you've heard of that, which is a process by determining how old things are, at least things that used to be alive. The periodic table displays many categories of elements. For example, metals are on the left side of the periodic table. Remember, metals are malleable, ductile, and conduct electricity. Nonmetals are on the right-hand side of the periodic table, with metalloids in between on the staircase in bold. Metalloids include boron, silicon, germanium, arsenic, antimony, selenium, and tellurium, and have some of the properties of metals and some of the properties of nonmetals. Go to the link displayed above and learn the locations of the following. Take time to stop the presentation if you need to pull that link up and look at it in another window. You'll see that the alkali metals are those metals in group 1A in the leftmost column. Columns go up and down, by the way, and rows go to the left and right. The alkaline earth metals are group 2A, or the second column on the left. Representative elements are the left 2 and the right 6 columns of the table, whereas transition metals are all the elements in between the representatives. You're also responsible for knowing the lanthanide elements on the periodic table, how to identify actinides on the periodic table. These are the 2 rows at the bottom, starting with lanthanum and actinium. And you should learn to recognize halogens and noble gases, the last 2 rows on the periodic table as well. Alright, this concludes the first lecture of Unit 2.